Hi guys, today we're going to think about how we can find the length between any 2 points on an xy coordinate axis. Now before we do that, we actually need to do a little bit of recap. We need to remember Pythagoras Theorem. Now Pythagoras Theorem involves a right angled triangle with side lengths A, B, and C, right? This C here is called the hypotenuse, the longest side. And what Pythagoras tells us is that A squared plus B squared must equal C squared. Okay? In other words, if we take each of these smaller side lengths, square them and add them up, it will equal to the longest side length squared. Right? That's Pythagoras theorem. So let's think about how it applies to our problem here. Right? We've got 2 points, A and B. A is at the point 4, 3, and B is at the point 12, 7. How do we find this length here, the length AB? Well, what we could do is we could make this into a right angle triangle. So let's do that. Right, here's our right angle triangle. And so I'm saying that if we know this length here and this length here, then we could calculate AB. So how do we do that? Well, let's try to find those distances. If I draw this line down here, I can see that the x-coordinate value is 4. If I do the same for point B, the x-coordinate value there is 12. So with that, I'm able to calculate this length because it must be 12 minus 4, 8. I can do the same thing with the y values as well, right? This y value here has got to be 3. And if I draw this one across, that y value there is 7. So I'm able to calculate this side length now, which is 7 minus 3, or 4. So now all I have to do is just use Pythagoras, right? I can say that AB squared, the hypotenuse squared, is equal to 8 squared plus 4 squared. And 8 squared is 64, 4 squared is 16, so AB squared is equal to 80, or AB is equal to the square root of 80, right? Fairly straightforward. So let's see if we can apply the same principle to the general case, right? Here again, we've got 2 points A and B, but this time the coordinate values are just generic values, x1 and y1, and x2 and y2. Are we able to calculate the length AB in such a case? Well, we're just going to do the same thing. We're going to try to turn this into a right angle triangle. And what we want to do is we want to find out this length here and this length here. So how do I do that? Well, let's draw this line down. That x coordinate value is x1. That x coordinate value is x2. So what's this bottom side length here? Well, it's got to be x2 minus x1. And I can just do the same for the y values again, right? This y value is y1. And this y value here, it's got to be y2. So I know this side length here must be y2 minus y1. So now that I know that, well, calculating AB is just using Pythagoras again. AB squared must equal to x2 minus x1 all squared plus y2 minus y1 squared. So that's where the formula comes from that you may have seen before. It's always important to know that maths isn't magic. It should all make sense, right? It comes from somewhere. So I think now is the time for you to do a practice problem, see if you've understood what I've said. Pause the video at this point and try to do this yourself. Find the distance between the points -1, 3 and 5, 6. Well, let's try to do that. Let's find this. We'll call the distance d. So d squared has got to equal to x2 minus x1. So we're going to have 5 minus -1 all squared plus y2 minus y1. So 6 minus 3 all squared. Okay. So 5 minus -1 is 6. 6 squared is 36. 6 minus 3 is 3. 3 squared is 9. So d squared is equal to 45. or we could say that d is equal to the root of 45. Okay, so that's fairly straightforward. However, before moving on, I want to show you that actually we could reverse the order that we take these points in. Right? Let's turn the order the other way around. We'll consider this one to be the point B and this one here to be the point A. Let's see if we get the same result. So the distance squared is going to equal to x2 minus x1. So you see I've switched the order around. Right now we've got x2 is -1 and x1 is 5. So we get -1 minus 5 squared. And we're going to do y2 minus y1, so 3 minus 6 squared. So what's going to happen there? Well, -1 minus 5 is -6. Minus 6 squared is 36. 3 minus 6 is -3, and -3 squared is 9. So you add those up, you still get 45, which means that d is equal to the square root of 45. So it doesn't matter what order you take your coordinate points in, right? Because you'll get the same result, because when you square things, the negatives will become positives. Okay, so you don't have to worry about that. All right, well, we're very close to being at the end. We just want to consider a slightly different problem now, right? We've still got the points A and B, but notice here that what we have for the y coordinate of B is an unknown value, right? That value there is P. So I want you to consider the question, if the distance AB is 2 root 41, right? If we already know that distance there, then can we find the value of P? Well, let's just try to apply our formula as we've done before. Okay, we know that AB squared must equal x2 minus x1, so 15 minus 5 all squared, plus y2 minus y1 all squared. So we're going to have P minus 4 squared. Well, AB is 2 root 41, so we'll just put that there for the time being. We've got to square that. 15 minus 5 is 10. 10 squared is 100. And P minus 4 squared, we can expand that. We'll get P squared minus 8P plus 16. Okay? So we've got to simplify this, right? 2 root 41 squared is going to be 4 times by 41, because we square the 2 and we square the root 41. And that's going to give us on the right-hand side P squared minus 8P plus 116. Now, 4 times 41 is 164. And if I subtract that from both sides, I'm going to get P squared minus 8P minus 48. And we can factorize that, right? That factorizes to give P minus 12, P plus 4. So actually there are two solutions that we could have. We could either have the solution P is equal to 12 or P is equal to minus 4. And actually that should make sense if you think about it, right? So the value that we've got up here, it does look like that value is going to be P is equal to 12. But actually if you think about it, we could have another value down here, right? That would have the same distance from A, right? These two distances would be the same, right? But it's just below, right? It's down, right? So what you want to see is actually there are two perfectly legitimate points that would satisfy this particular problem.